So let me take a stab at what the physical infrastructure might look like if I was to build out a Kubernetes cluster. Now, this is based on some kind of preliminary knowledge here where I've had my head in Kubernetes studies and I've been digging into the concepts and beginning to work with clusters and get a sense of what all Kubernetes can do, what it's intended to do, and so on. But the keyword there is preliminary. I'm not completely through it all. I haven't actually reviewed architecture documents in too much detail, but I think I am starting to get a sense of what all of that might look like, and it's not really anything exotic. So let's take an enterprise scenario here. Let's talk about where most companies are at. By that I mean most companies are not massive and they don't have huge computing needs. They're not scaling to hundreds of thousands or millions or larger users. They're supporting a small number of users, and they got some apps and so on for their internal employee base and maybe some of their customers and so on. But they're not massive, right? And you can do an awful lot of compute in a rack. So let's start with a rack. What does a rack look like if you're supporting a Kubernetes cluster in that rack? Well, you might immediately say, Banks, I'm going to spread it out into multiple racks. Fine, you might. But let's just consider a rack as a unit of compute that we want to use to deliver a Kubernetes cluster. Let's start by defining some terms. What's a Kubernetes cluster? Well, a Kubernetes cluster is made up of a bunch of nodes. A node is it's a server. It's got CPU, it's got memory, it's got storage, or it attaches to storage, whatever. It is a block of compute. That is a node in Kubernetes parlance, and there are two kinds of nodes. There are master nodes and there are worker nodes. A master node is the control plane. That is where the Kubernetes processes run. The scheduler and a whole variety of other services that run on there that keep the Kubernetes system up and running and make the Kubernetes system work. And you can say, I think fairly, that Kubernetes runs on Kubernetes. That is, once you fire up the Kubernetes system, there's a little bit of inception there where a bunch of pods and that are running Kubernetes-related services are launched on the infrastructure. Okay, so you've got the master node. Those are running those kind of services, and by default, master nodes don't accept any compute. They don't accept any containers to run on them. They're isolated and protected to keep the Kubernetes system running. There are ways that you can put workloads on a master node, but you wouldn't do that by default. Okay, so if you have master nodes, then you also have worker nodes. Your worker nodes are the servers that are going to run your containers. I'm saying containers because that's the typical workload kind that you're going to see in Kubernetes. Not the only thing, but that's pretty much what we're talking about. We're talking about Kubernetes. It runs, manages, brings up, and takes you through the life cycle of a container. Another term we need to understand here as we're talking about what this rack of ours is going to look like. You've got a Kubernetes pod. Well, what's a pod? A pod is the smallest work unit, or workload, I should say, in a Kubernetes cluster. A pod typically has a container in it. There are isolated instances where you can have more than one container in a pod because those two containers are very tightly coupled for some reason. That is somewhat rare. Typically, a pod contains a container, and that's it. When you're dealing with Kubernetes, you are dealing with pods. A pod is the thing that is being deployed to a node so that it can run, and it's got a container inside. You deal with pods in Kubernetes. Pods run on nodes, and again, specifically, worker nodes, typically. You could run a pod of your own, with your own container and application on a master node if you change the default behavior. Let's assume we're going to leave the master nodes alone, though. We're not going to change the default behavior. And let's assume that we're going to have, therefore, in this rack, some servers that are dedicated to the function of the Kubernetes control plane as master nodes, and we're going to have servers that are dedicated to the function of the Kubernetes data plane as the worker nodes. So we'll have some number of servers in that rack. We'd have, I think, at least 3 master nodes and at least 3 worker nodes at a bare minimum. That comes to mind as the right place to start. You've got some redundancy. You've got the ability to move workloads around if you need to do upgrades while still having redundancy. So that's like your minimum. Your 3 masters, 3 worker nodes as again physical servers. So now we're up to 6 servers in this rack. They don't have to be physically large. They could just be 1U pizza boxes with some CPU and some memory in there. I'm not opinionated about storage as yet, just because I haven't studied that, and I know that's another one of those things in Kubernetes where that's a potential issue. But I do know there are a bunch of storage solutions available for Kubernetes, and so if you wanted to go with a distributed storage model where you've got disk in the server and you're distributing your storage across disks in a bunch of servers in that rack, that's a thing you can do. Again, haven't dug into it, so I don't have too much of an opinion, but let's assume for this context that's what we're going with, because then we're not dealing with a separate storage array because, hey, who wants to do that in 2020 anyway, right? All right, so I've got my minimum of 3 master nodes and then 3 additional physical boxes that are my 3 worker nodes. Now let's talk about plumbing for network. Top of rack, I am going to want to attach these servers with at least 2 by 10 gig, and maybe larger. Maybe if you stepped up to 2 by 25 or 2 by 50 or 2 by 100, depending on your server platform and what your top of rack is configured as. Those are all options for you. And this is not going to be covered any differently from any other network capacity planning that you would do. You would consider, let's take something very common like a VMware box, a vSphere host that's got a bunch of virtual machines on it. How would you plumb that? Well, based on what the nature of the VMs are running on that vSphere box, you would determine how much is an appropriate number of network interfaces and how large each of those network interfaces should be, so that you've got lots and lots of bandwidth, so that the network interface does not become a bottleneck for those workloads. I think it's the same logic here with Kubernetes. Nothing mystical here. We've repackaged the work in that the work isn't in a VM wrapper. Now it's wrapped as a container, and there's this scheduler that's sitting in the background doing things. But again, I don't think that changes how we think about how the networking should be done for these devices. It's the classic more is better. As much as you can afford, that's really what you want to do. And then for redundancy, you'd want to dual attach each physical server. So at a minimum, that's what you're looking for. If you've got 4 network interfaces, great. You're going to plumb all 4 of them up to those what would presumably be 2 top of rack switches that you've got that are. I'm making a few assumptions here about what the rest of the network goes. What are those top of rack switches plumbed to? Well, they're on unique power feeds. They have redundant power supplies, and each power supply is hooked into a unique power feed. They are plumbed off to 2 other boxes at the next tier of the network, whether that next tier is core, kind of a setup where it's a traditional access or maybe an aggregation layer and some core, or whether it's a leaf spine where the top of rack switches are actually 2 leaves in a glow fabric, something like that. And again, we're talking, I set this up as being a small 1 rack install, right? We're not designing a huge data center here. But I think this is all valid discussion points. The dual plumbing coming out of the physical server from a Kubernetes perspective means that node is less likely to go offline and be no longer available to the Kubernetes scheduler as a resource. You want it just, and again, this is just like any IT system. You want to, without going crazy, you want to minimize the chance that node, that server, is going to go offline and not be available to the Kubernetes system. So again, this is normal best practice kind of stuff. You don't. So there's a caveat here. that is crossing my mind. Is why I'm hesitating and sighing a little bit. When you think about deploying applications in a Kubernetes environment, you are actually thinking about small workloads typically, not big monoliths. Therefore, I think if you're dealing with applications that have been deployed in that manner, where you've got multiple copies of that workload running that are available to support your users, you can afford for a node to go down and be fine. If you've done your capacity planning correctly, that is, you aren't running every node in the Kubernetes cluster at 80+% capacity for CPU and memory. If you lose a node, then that's fine. You lost a node. I'm sure there'll be some ripple through the universe that'll happen depending on just how sensitive the application is to being disrupted. But on the whole, if you've broken up your application into microservices, you've made copies of those microservices and spread them out across a variety of physical nodes. And honestly, our conversations about a rack, a single rack, but if you've got multiple racks and you spread your load out into multiple racks or into multiple areas of the physical data center, well then, you've got all kinds of redundancy there in the number of copies that you might have spread out. What Kubernetes would call a replica set, or deployment. It's another Kubernetes term, deployment, which will bring up a replica set, which will put copies of pods out everywhere that they need to go, distributed across different nodes. All of that to say, go back to our physical design discussion and thinking, does it have to be the most robust server ever? Does it have to be the most super crazy piece of network equipment with redundant power supplies and all that stuff? Not really. Why buy, if you're going to buy 2 switches and stick on top of a rack anyway, why are you going to buy redundant power supplies in each of those? Why don't you just leave one power supply in each of those switches, plug one of them into power source A and another into power source B? So that if power source A takes a hit and you lose that one switch, you still get the second switch up, and that's fine. You don't need to be like, oh my gosh, I've lost a switch. Yeah, you lost a switch, but that the application is designed to handle that. You're under-provision your capacity. You're not overutilizing the capacity that's there. You're keeping that reasonable. So if you lose a whole bunch of network capacity because of a power failure within the data center, or at least the rack or something, then it's okay. That's the point. So therefore, save a few bucks on that switch and don't stick a redundant power supply in it. Why bother? Do you need to plumb that switch to 15 different spine switches? Well, you got the other switch there. Sorry, 15, that's an odd number. It would be 16, clearly. But you've got some amount of redundancy to go back to 2 spines, but if you lose one of the spines, you want to talk to at least 2 spine switches, probably 4. And if you lose one of them, okay, I said probably 4. Maybe not. Maybe you only need 2 spine switches. If you're a small shop, you can make some pretty monster-sized spines with chassis switches, which I know. To be fair, I haven't checked their reference models in a while, but I know Arista was recommending that at some point because, hey, they got chassis switches to sell. So it's like, yeah, build a big monster spine with, you can plumb a ton of top-of-rack switches, leaf layer switches into our chassis switch. Okay, point being, you can get away with an awful lot of top-of-rack switches plumbing into 2 spine switches, and so do you need to buy a switch that has 4 uplinks into the spine layer? Or can you get away with just 2? Or if you buy one with 4, do you have to populate all 4 of the uplinks into with optics? Those optics being tends to be pricey. Well, hopefully you're not still buying from vendor branded optics and you're buying from a third party because you like to keep your budget. But even still, there's a lot of money tied up in optics and buying optics. So maybe you don't have to populate that switch with additional optics. Maybe you don't have to populate the switch with an additional power supply because the second switch is really your redundant component, and you got to think of it that way and plumb it accordingly. The point being, you can save money and you can get a great level of service and a great amount of uptime. Even the hard failure of an entire switch going down doesn't diminish the ability of the Kubernetes cluster to deliver that application. So there's a long way to say, if you are in a position where you're standing up a Kubernetes cluster because you've got an application that can leverage Kubernetes, that's a thing that makes sense for your company, maybe it's also time to think about how redundant is redundant enough, and why you're spending extra money on in-box redundancy, as opposed to saying, hey, if I lose the whole box, that's fine because of the way I plumbed everything, which I think is where you need to go. This is a very long diversion from kind of my core point here, which was, if we go back to mapping out what this rack would look like for a single Kubernetes cluster in a rack, let's say, which you can go way bigger than that, but we're just trying to come up with an isolated use case. 3 master nodes, servers, 3 worker nodes, servers, dual home each of those into 2 top-of-rack switches. Keep the top-of-rack switches to be simple. Dual home them back to something in the core, your spine layer, and split your power appropriately, of course. And if you've done all of that, what you've created is a system where all of the servers in the cluster can talk to each other. That's a big part of what Kubernetes needs to do. And they can do it redundantly because they have redundant uplinks, and the switches themselves have redundant uplinks. You can facilitate the same sort of redundant communication and connectivity from the Kubernetes cluster to the outside world, because you're serving these apps to somebody. It's not just Kubernetes Kubernetes nodes and pods talking to themselves. You're actually talking to someone out there, and you're delivering the same kind of redundancy. You're not overutilizing your links. You're not, provisioning and then using everything at 80%. You're keeping it so that your capacity management style is such that you're at peak load. You're still never exceeding 50% utilization across the cluster. Therefore, you could lose half of your capacity and still be within tolerance, even at peak time. And that's good. That would be very small scale. Of course, the bigger you scale and the more physical devices you scale across, then of course you can move to higher amounts of capacity, because the amount of capacity you're losing doesn't hurt so bad when you're spreading out Kubernetes pods across nodes that are spread out across racks and racks and racks and racks and racks, and on a massive deployment. It's again, you're playing a different game at that point. But I'm talking about very small sort of deployment here. In other words, there's nothing exotic here that I'm seeing as yet. Now, would you put load balancers into this rack with the Kubernetes cluster? No, I don't think so yet. Maybe there's some use cases and some scenarios for that. Would you put firewalls into this rack? No. I mean, I'd be much more inclined to be going with like a microsegmentation sort of a strategy and integrating that with Kubernetes filtering that controls what can talk to which you can build some policies for that, or layer on a microsegmentation product. I'd be pretty not interested in standing up physical firewalls for this at all. You really want all of that to be policy driven. And again, this is something I haven't dug into in my Kubernetes studies yet, but my intuition suggests at this early stage, you're going to be using labels in the Kubernetes world to group devices together and then set up security among all of those devices in that way at a software level, not a hardware firewall. So I don't think I see anything in this rack in my mind beyond compute and network. maybe I'm wrong there. Maybe I'm missing something else that you'd have to have, but I don't think so. I think all of the other traditional IT services you layer on, like storage, that's going to be in the rack in the servers themselves. Like security, you're going to do that in software and layer that onto the cluster. Um, and gosh, I don't see that you need anything else in that rack. So use all 42U for compute if you want. Build yourself a big old cluster. Have some nice non-blocking top of rack switches, and off you go. This doesn't say anything about provisioning the cluster itself or what other tooling you might be using to manage the cluster from components that are outside of the cluster. You might have Ansible boxes and CI/CD pipeline kind of stuff and so on that aren't necessarily living in the cluster. And that's a different discussion. We're talking about a Kubernetes cluster itself specifically for delivering apps. And again, this is my kind of top level of thinking it through how I would design it if I had to go with the knowledge I had now and had nothing else to go on. How would I do it? And for small scale, that's how I do it. That's really how I do it. That limited, compute, 2 top of rack switches plumb appropriately is where I'd go. Now, that doesn't say anything about building it in cloud or anything else, which is a different kind of discussion. I'm a bare metal guy, have been for a long time, so that is where I think. Primarily, that's the first place my brain goes. But you're exactly right that there's a whole big discussion to have around standing up Kube in the cloud and what that might look like. I will just point out quickly that there are Kubernetes as a service offerings all over the place, and I think it's less of an infrastructure thinking sort of exercise, although there's still definitely that component with availability zones and geographical regions and so on. But it's less about the infrastructure and redundancy and all that, because the cloud provider gives you that, and much more about availability and cost and not over provisioning yourself when you are in the cloud and leveraging that Kubernetes as a service offering. Topic for another day.